Hello, everyone. My name is Chris Whitmire. I will be hosting the next session, which is Game Changers, How Technology is Revolutionizing the Sports Fan Experience. When you came in, you should have received a raffle ticket. If you have not, please be sure to go back and get one, but do not leave the room. We've got some great presentations coming up. Raffle ticket, we'll be doing at the end of this, next session, and we've got some great merch, provided by Amblin Entertainment. But for now, let's hop into the next session. First up, we have Chris Wells. Chris has a background in niche journalism and was once an aspirational archer. Working at the London 2012 Olympic Games, he led the role at World Archery, where he was responsible for innovative digital strategy that sees sports significantly outperform its market share and forging an innovative new path for broadcast that focuses on an audience and sustainability. Please welcome Chris Wells.
Thank you, Chris. Thank you, Simti. Thank you all for this opportunity to speak to you a little bit about what we're doing as a niche sport in the broadcast industry. I've got a small video to kick things off, so if you don't mind.
Ladies and gentlemen, a very warm welcome to you as we get ready to welcome the world's greatest archers to go all the way to the highest step of the podium.
Just the reception issues. The Olympic champion is now the world champion.
That's very short, but that's the vibe. That's what we do as archery. LA is a big thing for us. Being here in Pasadena is a great opportunity because in just a couple of years, the Olympic Games will come to Los Angeles. Do I click? Oh, yeah. I could talk a lot about what we're trying to do as a sport, but really it comes down to one key thing, and that's the move into the IP industry, which is obviously a large part of what our keynote speaker spoke about. I'll talk about the problem initially. Olympic sport comes from the Olympic Games. The production of Olympic sport comes from the Olympic Games, and it's good. We all know it's good. It's high end, but it's expensive. So our top tier events, they cost us approximately $20,000 an hour to produce, and we only make approximately $11,000 an hour in rights. A fundamental issue because very difficult to scale, and that money has to come from somewhere. So the question has always been, how do we bridge that gap? And when I looked at distribution and the core to it, everyone told me moving to SRT would be a terrible idea. The latency, I can't do live sport with additional delay. The reliability, public internet, not good enough around the world. And the risk, I don't have a provider. It's a single point-to-point transaction. All those things are true, but I've also been asleep on a field in the middle of Guatemala when my OB van didn't arrive with 2 hours left to go until production. It worked out in the end, and we have other risks as an international sport operating around the world. The first goal was to go to remote, semi-REMI, whatever you want to call it. We took productions in different parts of the globe. We transmitted through satellite, found an MCR, and pushed as much as we could away from on-site production. But as I said, working internationally brings up other challenges. The tour that we had this year, we've been to China, we've been to Korea, we've been to Turkey, we've been to Madrid, many places, and the infrastructure is entirely different in each spot. So while this masks some of our long-term issues, it didn't solve the problem that we were losing money per hour of broadcast. Every time we wanted to scale, every time we wanted to add another hour, it cost us more, and there's not an unlimited pocket of cash waiting by the side of my desk to dive into, unfortunately. So we decided to do this and ditch that unlimited pocket of cash requirement for distribution, for contribution, for the movement of signals. At the start of this year, we invested in SRT. We moved everything to SRT primary. That goes from contribution at our top tier events, using our owned OB or owned managed OB, and all the other events. The cost for doing an hour of distribution has suddenly become zero. The cost barrier to entry for someone to take the production or deliver a production has become zero. And that's allowed us a level of flexibility that no other sport, I believe, has at this time. Yeah, I've spent some of that money. I've spent some of that money on an owned OB container that delivers super high level production to Olympic or World Championship standard. But it also does arrow tracking with LiDAR and some other cool stuff that, I would love to tell you more about, but I've got 5 minutes and 34 seconds left, and I'm very aware of that time ticking away. It looks cool as well. It's painted. But most importantly for me, we've been able to put SRT encode and monitoring on site for our owned events. So using those top tier, those small levels of top tier, 10 a year, shipping them around the world so we have a consistent level of production. We've also been able to test and develop a consistent level of contribution using SRT only, SRT and public internet. I would love to put archery on dark fiber, but again, my unlimited pot of money doesn't exist. But this is not the end goal. This has just been a step on the journey. Building this container, building our own OB, our own distribution or contribution method has been a test case for everything else. I'm super excited about the top tier, but I'm even more excited about the low tier and the availability of low quality content for niche sport. Before it was either broadcast or streaming. And I believe as technology progresses, as everything goes IP, as everything goes software based, that gap is disappearing into the ether. So our real focus now we've moved to SRT and IP first is on the low level, where from the start, the cost is the same as the income. And that income comes from betting rights or distribution or whatever you want it to be, but it's cost neutral from the beginning. Using SRT encode cameras, using low-level SRT encode, but using our existing infrastructure for top tier, we're able to add hours upon hours upon hours of events until there are no more events to add. It all goes through my MCR, my tiny little MCR in Lausanne. Some of it is real, some of it is on site, some of it is expensive, some of it is cheap, like the test generator I did in ChatGPT and a Raspberry Pi. Some of it is clouds, graphics, archive, production. It's not a typo to say insert, it's just that we're agnostic. Because we're basing it on transport streams and basing it on the IP infrastructure, we can scale, we can use whatever is necessary to deliver the job. And there's a little signal map of how it all fits together. We're not trying to replace distribution agencies. We're not trying to replace, the wider production world. But by putting our content through an owned SRT infrastructure, we are able to scale. We are able to give consistent outputs. By not making things baseband in the middle, we're able to be more stable, more reliable, and reach more people. Not just for the top tier that we own, the top tier that we're producing with our nice blue cube that ships around the world, but for all those one camera and all those other events. We can act as an assistant to lower level leagues, if you will. And we can scale with the cloud production, external PCRs, because everything is SRT based and everything goes through the same output mechanism, the same monitoring mechanism internally, RTP based, not SRT. Archive, all in the cloud, all SRT based. Output to satellite, SRT through a port, and to takers directly. The number of broadcast takers that have now switched to receiving the signal directly from us is far beyond what I expected and has accelerated our take-up of SRT and our move away from satellite permanently over the next 12 months. So I think now that SRT is a great idea. Yeah, there's latency, 100%, but we're a niche sport and we had problems anyway, right? Now we can quality control everything from a traditional broadcast, a semi-REMI, a full REMI. We can adjust latency on the MCR end, not just on the production end. There are reliability issues, but they're manageable with telco managed internet on site. And we now know exactly where the problem is at any given time. I'm sure we've all had problems where a satellite, doesn't connect, or there's something that we can't really work out why it's not functioning. Now, with the way that the SRT infrastructure works, I know where the problem is at all times. And there is risk. People can take a risk on our content. There's no cost for a taker to downlink an SRT normally. They have their own decoders. So more and more people are taking archery, are showing archery, and are using archery. There's more reasons as well, not just the three that I was told at the start. It's future-proof, right? We can scale to any IP technology that's coming in the future because we're already in transport streams. It's flexible. We've got decentralized providers. And as long as we stick to those and we don't look at building a bigger infrastructure, we can democratize both our production and our distribution. And it's scalable. And I think by using SRT and using it in this way, we may get to viability, cost viability for a niche sport. And that would be something pretty cool. That's my talk. Thank you very much.
Thank you, Chris Wells. I've had an opportunity to get to know Chris and World Archery over the last couple of months. We've been chatting. Just a brief presentation. Super fascinating guy. You should try to find him. And with that, there are QR codes taped around here. Feel free to scan those and ask questions. We will try to do a Q&A at the end of this if we have enough time. Next up, we have Brent Angle, CTO of Synesys. They've been doing integrations for sport venues for many, many years, including I worked with him when I was at NASCAR. He's worked with NFL, PGA at some point in time. I will get this list wrong, but he's worked and helped integrate with all these different sports leagues. So with that, welcome Brent Angle.
How's everybody doing? Loud, too loud? Everybody hear me? All right. Why am I here? I am the one speaker out of this group that doesn't have a British, Australian, New Zealand, or South African accent. So that'll be So I was asked to briefly present, some of the projects that we've been working on, what we see as technology and engineering trends, that would be applicable to a lot of our fellow SMPTE members. So I'm going to kind of breeze through this in a 10-minute presentation. For those of you in the room that know us, we are a specialty integrator. We do design and build for sports, media, broadcasting, and basically it was refreshing to see the NEP presentation because our company is kind of very similar in the way we do projects. We have software only design build where it's just API integration. And then we also have physical engineering infrastructure where we're actually building things on site and everything in between. Our current list of customers, this is what you accumulate when you've been in business for 27 years. So we've been at this a while. We always tell people we may not be the best, but we are the most stubborn. We've been around a while. Current trends. So I guess one of the things that I'll start off with for those in the room, how many in the room either are involved in engineering or supporting 2110 and their infrastructure? Just a show of hands. Okay. Every year it's a little bit more. We're seeing the same thing. We continue to implement 2110 into facilities. Sometimes it's a full scale, everything end to end we're going all IP based for the infrastructure. More times than not, especially in the last few years, due to budgetary reasons, all of our broadcasting clients are very challenged on that level. We're simply implementing 2110 into specific areas, and we're still utilizing their SDI infrastructure. So it's been more of a hybrid approach. The other thing I'll briefly talk about, we're starting to do more and more projects where we're building out production studios that are utilizing XR and AR. Once again, this is so that people can deliver a very high level product, but do it with a lot less cost. And then the other thing, which is kind of interesting to the NEP we about 3 years ago at our company, we built an entire team because we saw the future of orchestration. So we're actually doing design build around orchestration just as a a product and a service using software products that are just isolated orchestration tools, not affiliated with any one software or hardware vendor. So I'll kind of dabble across these three topics very quickly. And then at the very end, if anybody has questions at the end of the meeting, I'll be at the back of the room. I'm happy to answer any questions about things that we've run into. So for 2110, adoption is still slow. I think 5 or 6 years ago, right before the pandemic, I thought, we would have everybody on IP right now, but it's been slow. And, so as I mentioned earlier, we're mostly doing a hybrid approach. Reasons for that, the initial cost is still higher than to update a SCI infrastructure, especially with endpoints. Some of the endpoints we still don't have 2110 availability yet. The other reason, as also mentioned earlier, the network complexity, and the fact that there is a real shortage of engineers, in our field. I have a hard time. I mean, it's just, I go through lots of resumes and it's just hard to find people. We have the most luck to stealing people away from other people. That's kind of what's been happening. And then of course we're still having issues. I thought, we'd have all the NMOS stuff sorted. How many people in the room also occasionally have an NMOS issue? Show of hands. Oh, that's getting better. So that's kind of basically our overall, what we're seeing in the trends around 2110. The next round of projects that we've been working on, is, XR and AR. We're currently, we finished the design earlier this year. We're doing the build now on a studio, which will just be, the whole studio will be 5 robotic cameras. There will not be other than the talent, there will not be, human beings much on the set. It's going to be completely robotic. It'll have a very high level look, but be able to do productions on a budget and with a lot less people, but still have the production value up there. We're seeing more and more AR graphics where we're getting called to integrate those into the broadcast. A lot of this is driven by orchestration automation. It's to take all this data that they already have, real-time stats, real-time endpoints. The speaker after me is going to talk in more detail about that. But everybody has all this data. They want all this to generate graphics in real time to add to production value. And then the other one that we're getting more, this has been a learning experience for us, is all the various robotic camera systems. And we're doing a project now with one of the robotic camera companies out of France that just got acquired by EVS. So everybody keeps buying these small companies that have this really cool technology. They get absorbed. And, so that's been a current trend for us. And, we're starting to do more and more projects around this, it's really interesting. And we like learning new stuff as well. This is very new to us. And this is the one I'll probably talk on the most, as the other person mentioned, like I said, about 3 years ago, we dedicated a team, for just doing design, build, and integration around media orchestration. And for us, we do feel like this is the future because this is where we're going with third-party orchestration platforms that aren't tied to a specific vendor. And it's all API driven. And what we end up doing is, we end up building these out so that we can create orchestration and automation across our facility. Just about anything that has an API that they want to have automation or control over, or they want to be able to have monitoring, then we can tie all those together with a third-party platform. We're doing a project currently for the NBA. We just started orchestration for a very similar process. They have all the arenas. They're managed in Secaucus, New Jersey. Orchestration will be there, and we'll be automating some processes for them, starting off with kind of a phase 1, and we'll be adding more to that. It really allows us to take a very organized approach of having lots of different manufacturers, encode, decode, distribution, and we can basically automatically build processes that are very repeatable and very predictable. It also allows us, as I mentioned before, about being able to automate all of this stuff, being able to create consistency, especially with our sports broadcasters, being able to automatically orchestrate and assemble melts and deliver them in a consistent format to where they need to go. We do view that the orchestration will be the glue, that will tie all these things together. And one of the things that we've been doing a lot of is we build the tools. So we'll build the orchestration platform, and we design all the software endpoints. But what we are also doing is we are building these as modules so that the end users, after we turn this orchestration over to them, they can basically go in with low code. Anybody in the room know what I mean by low code before I just throw that out there? So low code basically means that you're developing these scripts at a high level, software programming or software engineering. But then when you basically deliver the module, it's in human readable form. It almost looks like a script. So they can simply take this code and they can go in and just modify the things that they need to. Think if you did an import for, you built a module for encoding and you built this complex workflow and you have some customer that changes what they want to deliver. That never happens. A customer never changes their mind. So we don't have to go back and re-hard code all that platform. They can simply go in and just modify that variable or that input at low code without having to be a software engineer. They don't need us to come back and write this code. So we're trying to work ourselves out of a job. We want to hand over a system that's easy for the customers to modify as they need because their needs are going to change daily or monthly. So that's really, what we've been spending our time. Those are the kind of projects we've been working on, especially around the sports broadcasting world. With that, I think I'm out of time. So that's going to be it for me. Short and sweet.
Thank you, Brent. Okay. Turns out that I might become vintage soon as well because I need readers. Next up, we have Jan Schaffner. He's the program manager for the Americas region at Real Communications. Jan, please join us.
So check 1, 2. I'm going to be the speaker with the German accent, and which you will probably notice today. And I've traveled all the way to Germany, and I'm very delighted to be. I was invited here today to speak to such a talented group of people. I'm going to talk today about nothing because. Oh yeah. There we go. About RevCam. And for those of you who probably live under a rock and have not seen the Club World Cup, it was largely displayed during the Club World Cup and spoken very heavily about by the FIFA committee and especially also the head of refereeing, and was quite a huge achievement for us. But if we're talking about the RevCam, we're mainly talking about a system that consists of 2 units. So we have the head unit that is located on the otoplastic or the ear mold of the referee, and we have 2 back units. So one transmission unit, which we call the live unit, and also the recording unit. But it's safe to say that both units can do recording, so to use this for post-production purposes or whatever. And developing such a camera was really a challenge for us because we have to be really careful and really, really mindful whenever we put sports onto technology onto a sports body, because those officials are also athletes. And we cannot just simply throw more and more tech on them and expect them to just accept this, because at a certain point they will look like Batman and will not be able to do their job. So we had to be very, very careful about that. And I know that we are not the first ones who tried this. There have been many approaches out there. Many people tried this. We've seen this mainly in rugby or other sports, but I think it's safe to say that we took it to the next level. And I'm not shy to also say that there's like quite a difference. I think our technology is just very small, very light. It has it's a great performance. And I think we really delivered on that one. So looking into what RevCam can actually do. So the belt pack or the transmission unit is usually on the hip of the referee, or can be worn also on an arm patch. And there are also many other certain forms of adaptation that we can take. But what we do is we have a very lightweight head unit that automatically submits an encoded video to the transmission unit, which then can be used from the broadcaster to be output live on television. And we did that many times, not just with the Club World Cup. We also did this in the Bundesliga. We did this in the Serie A, which is the first Italian league. And we also did this with the NFL a couple of years back, actually, I think 3 years back, and at MetLife Stadium. We're filming a 4K image with a 4K resolution, and then outputting a full HD signal, so that it's going to be in full HD. And we're also supporting the American standard format. Please don't make me say it. I always screw that up. So it's 1080 I40 59.94. Yeah, kind of native. And we also have an IMU over serializer, deserializer. So that also enables us to do horizon leveling. Whenever we see that the camera is slightly tilted to the left or to the right, we can adjust this and also have remote controls to do some color shading, white balancing, and be able to adjust this when we see that the referee or the light situation is slightly changed. It is water resistant. So it is not waterproof, so I would not advise you to dive with this camera. But it is water resistant. And as I said, we have a live video preview to set up the camera, to adjust everything. And if we see that something is not quite right, we can also remotely control that and adjust that even after the referee is already on the pitch. And what is quite handsome is that we also now have 5G transmission. And that was also one of our milestones. One of our milestones was that we switched from a COFDM based method to 5G. Also now Riedel being able to, also being able to, supply their own 5G system. It is very good to have that camera run on our own infrastructure. And it helps us to usually also navigate around all the different, RF, issues that we see on those larger venues and also on those, more dense, venues like Super Bowl or the Club World Cup, where usually it's like a heavy presence and very dense environment. What we achieved as well is a rule change within the IFAB. So for those of you who don't know, the IFAB is kind of the governing body of FIFA that is making the rules of what can be displayed or what can be shown or what can be done actually in soccer. And it was really important to have that rule change to be then also able to put a camera onto a referee, because it was strictly prohibited before. And that also cost us then in doing the FIFA Club World Cup, which was a huge success for us and also an important milestone and proof of concept there. And we manufactured more cameras, because before, and it's such a unique product, we only had two, and it was kind of like Weekend at Bernie's, where we tried to pretend that we had more and do more demos and try to make it look more alive than it actually was. But right now, with having approximately over 100 cameras, we are able to do more demos. We also are able to look into other sports, look into other opportunities where we can show the camera. And that was really important for us. And this might sound simple, but this is a real own in-house development. So we did not just take a GoPro or Rilo cam and just like put it in a different housing and then present it as our own new solution. Is a complete new real in-house development that we did there. So in terms of our next steps is, as I said, the media backlash after the Club World Cup was quite great. We have a large list of demands and requirements that we have to look into as well. But there are also a lot of demos that we have to fulfill, and we really want to do that. We want to expand our cooperations because we cannot simply expect like customers always fall back on Riedel and their technicians on site. We also have to make this more accessible to our collaboration partners, and also to also other rental companies, so they can also then use this product in the market. And of course, we also want to create more units. So the start of the series production is currently being prepared internally and covering more and more market segments. But before I bore you with that, I would love to show you a video actually from the World Club that actually shows how close we can get to the pitch and how close we can get to the actual talents. And it's quite interesting to see, because it's a really interesting scene from the Club World Cup. I really do think that the product speaks for itself. And also seeing these emotions, like being that close on the field with your favorite talents, is definitely something that will change perception of the sport. All right. Apparently the presentation won't stop. I just tried to click twice. Now it is. Yeah, that'll be it. Thank you very much for your attention.
And our final presenter will be Sir Ian Taylor. Sir Ian Taylor is the founder and managing director of Animation Research Limited, all the way from New Zealand. He's a diverse background in sports broadcasting. I also found out he was the host of Australia's Funniest Home Videos. I was fascinated by that one. And he is also the recipient of the SMPTE Progress Medal, which will be awarded, I believe, this week on Thursday. So please welcome Sir Ian Taylor.
Thank you very much, Chris. Now, I'm the odd one out here. I know nothing about technology. I was born in 1950, and I can still remember at the age of 7, 1957, electricity arriving at our house. I was 11 when I saw my first television set, and the show was the Donna Reed Show. And I can see some grey hairs here, might have worked on it. So one of the things too, but what I do want to share with you is where we got involved in computer graphics and television. So I remember in 1989, a professor said to me, Ian, he was a computer scientist. He said, Ian, digital data is going to be the currency of the future, and the opportunity will be to turn that data into pictures that people can understand. That was in 1989. I thought it was inspirational. I already had a TV company at the time, so I still remember saying to Jeff Weibel, the professor, look, if we took what your students are doing here at university, doing that, and put it with what we do in TV, one day we might get a job in Auckland. We were in Dunedin at the time, and that was as big as our thinking was. So we just shook hands and put a company together in Dunedin. Now, one of the things about turning digital data into pictures that people could understand, we never set out to do sports. We actually did a whole lot of stuff. But New Zealand had just got involved in this sport called the America's Cup. And that was a sport no one understood. It didn't make any sense at all. So we asked the question, is there any data on those boats that we could use? And they said, yes, there's an XY coordinate at the back of the boat. So Dan talked about software before. This was a software solution that was created in 1992. The machine we needed was a $250,000 SGI machine to create it. We couldn't afford one of those, so we flew 2 programmers to Silicon Valley, and SGI lent us one to write the program on. So this is 1992 is what software was doing for the America's Cup. So you see there, as I said, it was a $250,000 machine. This is just an XY coordinate that now places those boats. So we track the XY coordinate, and we're able to put you in a virtual world that starts to explain what is going on the water that nobody understood. Because as you looked out there, you couldn't see the start or finish line. You still couldn't see any grids. That was 1992. This is Barcelona last year, where we delivered all that data on the iPhone you carry in your pocket. So those are the footsteps that come through. So every graphic you see on this is driven by digital data, and it's all coming through our hub to get it to air. There are thousands of pieces of data coming through that. But one of the things that we always looked on technology as, technology is just a tool to tell a story. And as we look at this here going through, look at the stories it's telling in real time now over real camera shots from helicopters, from 2 helicopters. Actually, I was going to change that one. Those boats travel at 100 kilometers an hour without an engine. So that's another story we tell. So I'm going to let it come down to the finish here, because look at all the opportunities there with promotion all around the walls. The only way you can tell where these boats are sailing is using computer graphics. And just to show how valuable that is, after this boat crosses the line, we'll show you what happens if the graphics fail. Suddenly, you've got no idea what's happening anywhere. So turn digital data into pictures that people can understand. We've taken another approach too. As we've looked at all these sports bodies that are collecting more and more data. Our approach now is how do we turn that data into pictures that they can monetize across all platforms. So here's a quick example. I just let this run of what is coming out of our little company in Dunedin. There's the America's Cup. We do all of the PGA Tour. And again, everything here is about telling stories using digital data. Everything is driven by software. There's the baseball. We do 3,500 games of baseball a year. And in fact, one of the things I just wanted to acknowledge the amazing camera that Jan and the team have built. Oh, over here on top right, that's AI telling us that the ball is going to go in the bunker before it gets there. So all of that is happening in real time. That's the virtual, Unreal Studio sitting in just down the road that we do the baseball on for Fox Sports. So if you watch the baseball, you'll see the final week, you'll see the umpire cams. And I'm going to suggest that they start to grab those of yours because they look really amazing, Jan. But you'll see at the baseball that's running this week and next week, we've just brought out the data coming into for the umpire. You can see all of the data of the balls being pitched, where they would have gone, and watch them going out again as well. So I think there was a couple of things: orchestration, collaboration. One of the things that I really want to stress as a little company from Dunedin is collaboration. We have collaborated with, so we work with Riedel. We work with a company called Bolt 6, who came out of Hawkeye, who came out of Hawkeye. We work with Hawkeye. There was this, I think sports, we do more than sports, but sports is the industry where all of this stuff really, really goes faster than anywhere else. And it's where we can collaborate and do stuff better. So I really encourage that to be a thought that you take away from here. Now, this is my son. It's taken, again, just staying with the idea of turning digital data into pictures. This is my son. I think he's about 13. It's 24 years ago in Hawaii. During Christmas, we would take him on holiday, so he'd work with us on the golf. So we've been doing golf for 25 years. He's sitting there. That's a GPS unit that he's got. So he'd walk out and stand by Tiger Woods' ball, push a button, send an XY coordinate to us so we could show people this is where Tiger Woods' ball is. This is how far he's hit it. This is how far he's got to go. This is what happens now. So my son still works for us, but he's got a different job now because these are the cameras. There's 140 of them that PGA Tour has rolled out across all of their tournaments. They're AI cameras. They track every shot of every ball, of every player on every hole. They actually monitor the walk and gait of all of the players. So the cameras tell us where Rory McIlroy is because they know where they are. Now, I want to share, this is the speed at which things move. So my son, Ben, who heads our whole sports operation, earlier this year when that data first came out, he's sitting in a truck on site when this data starts coming through. So this is the data now coming to us in the truck for every shot, every ball, every player. And this data you just saw there is for a 6.5 foot putt. That's how much data is coming now. So we've gone from an XY coordinate to that much data from a 6.5 foot putt. But here's the cool thing, because now I'm just going to touch on AI, because sitting in that truck, Ben is looking at this data and says, I don't understand any of it. Ben has never written a line of code in his life, but in the truck on Wednesday afternoon, he goes to an AI engine and asks it to turn that into code. That's the code it wrote in about, quarter of an hour. Ben hasn't written a line of code, so he then asked it to write a whole system that he could understand, because we don't know what any of that data represents. So here is the system that wrote again in about an hour. So here it is loading all of the data faster. That's every shot that it's got at the moment going to there. And then it delivers, and this is on a Wednesday afternoon, it delivers that data to Ben in a way that he can understand it. So look at the data we've got. Ball speed, launch angle, spin axis, carry distance. That's the data that's coming for every ball, How do human beings feel to that? We can't. We can't read it. So he wrote that program, and on Wednesday, tested it on Thursday. We went live with it on Friday, and we have been using that ever since. Not a code rotor in sight. Here it is telling us what the wind impact is on all of the balls that are going through. By Saturday, Ben had thought, actually, one of them isn't enough. So this is recorded in real time. Ben asked it to write another 4 versions of itself. And in the time I'm saying this, it's just written 4 versions of itself. So there is the example of everything that's happened. So we talked about AI, we've talked about machine learning. One of the things that we have just done is we have built a platform, and we've taken 10,000 hours of cricket footage, and I know for most of you that's a bizarre game, but we've taken 10,000 hours of cricket footage, and for the past year, the AI agent that we've been building has analyzed every shot in that 10,000 hours, so it can now give us a huge range of data to work from and to visualize. One of the things, and so this is just an example now of what turning digital data into pictures we can understand, because everything there is driven by data. There's the Apple Vision Pro, there's stuff in the studio. It's just a miracle of data. But I just want, as you are moving forward, to remember there's a saying in New Zealand, the footsteps we lay down in our past create the paving stones of where we stand today. And those footsteps are always in front of us. So I think simply you have an incredible amount of footsteps that you've laid down. Quite often you approach those by thinking they're behind you, and you look to the future to see where you're going. I would suggest, as you do, as our Māori culture does, we walk backwards into the future, never forgetting where we came from. And even as I stand here today and look at those pictures, I still see my son with a little device get an XY coordinate, and it comes as no surprise to me today that this is what we can do today, and we walk backwards into the future confidently. And I've only just really recently become aware of SMPTE. So for me, well, in the last 3 or 4 years with Paul, for me, it was a real eye-opener that this was an organization that is at the core of everything we do. I mean, it seems really crazy. Color bars and time code. Time code sits at the core of everything we are writing. Everything up there is driven by time code. So this standardization that SMPTE has brought to the sport is something I applaud. I congratulate you, and I feel really honored to be able to stand here today and share some of what you have made possible. Thank you very much.
Thank you. They've left me unattended. I believe I'm doing a raffle. Is there any adults around here that you're going to advise me on the next steps? I have no idea. Where's Maya? Any questions? Well, we got a few minutes. Yeah? Any questions for our speakers? Oh, we do. Excellent. I'm totally calling the audible here. Do we have a microphone? While someone finds Maya to see if I'm raffling off stuff from over here. Thank you so much. Can our speakers come up here? I'm not sure who's going to get the question. So Jan and Chris, Brent. How about? They're very shy. You were just here. Come on. Could you get a little closer to the mic? It's kind of hard to hear you. A little more volume. Thank you.
hardware-based ecosystem. In my own lab with strong generating AI different code orders.
Hmm?
Where do you make it?
That's a good question. Where is Dan? Our keynote speaker might also be able to help with that. The question is where do engineers fit within the organization as we bring about AI? You showed some great examples. I'll let one of you guys handle that really quickly while I find Maya.
Oh,
Get up there. Come on.
so I think every person's going to have their own spin depending on how they are delivering technology. But for us as an integrator, the API initiatives that we're doing around the software side, that tends to be the same group that we have implementing all of the AI, because the AI basically has to be incorporated with the traditional software layers. A good example of that is we have a lot of media asset management systems and initiatives that we're working on. Well, if you start introducing AI to identify things and you start analyzing hours and hours of footage, the hit rates that you get back are just, it's phenomenal. I mean, human beings can't make sense of it. It's too much data. So what we're actually doing is using traditional metadata that people have already had for years about their footage, and we're using that as a filter for the AI so you can find things very quickly. So I would say, to answer your question more specifically, at least from our standpoint, it's going to be your software engineers that are part of your software development teams and your media asset management and your API guys. I think those are going to be the type of engineers that you're going on more on the software engineering side.
If I could just add for one of that example I gave you of my son writing the code, he was writing it alongside a coder, and the coder looked at this and said, "Oh my God, what's going to happen to my job now?" And Ben's answer, and I think it's one we should all embrace, is that you will take AI much higher than I could. AI is a multiplier of the knowledge you have that you bring to it. So if as engineers, you bring all of that knowledge and embrace AI as a multiplier of that knowledge, there's a really wonderful world for engineers.
I think we've got a question. If you could read
Yeah,
that
a
back.
question came in via the QR code of Jan, which is, can RefView be used for VAR reviews?
So if we shut up. Okay. So the question was if we can use RefCam for VAR reviews.
Correct.
Okay, got it. So yes, I mean,
I could have, yeah.
it's difficult.
Yeah.
I mean, surely it can be used, but the question is, do we want to use it? I think this is something that we need to ask ourselves, because it's already a very delicate situation. And I know that not like a lot of like spectators are not really into VAR, because they do think it kind of hinders the sport and kind of also shifts it to like a more boring perspective, because you never know when you can celebrate or not. And the problem is that we usually see is, what is the referee actually seeing? So if we have the camera like in this direction or pointed in this direction, but the referee is actually looking somewhere else with his eyeballs, it is very hard to then say, well, why didn't he see that or this? So this is why it's kind of difficult, and I think a very political topic that also needs to be discussed by FIFA and IFAB. But
I think just seeing the quality of that camera was amazing. But again, if you watch the baseball in the next few days, the real great thing about baseball is you know where the umpire's looking. He's looking straight down that pitch at the square that's coming. The challenge that we have is that we are now tracking that ball from the pitch to here through the umpire's camera, but that's not, the umpire actually doesn't see the square. So the real risk that they've got to watch out for is a whole pile of all the audience out there going, I thought, how come he got that wrong? He can see it, but he can't. But sports like cricket and baseball, where the umpire's attention has got to be dead on straight down the thing, I think it would be really wonderful if we can deal to that other part where the umpire gets to see the screen in front of him as well, and I don't see that being difficult.
absolutely.
Any other questions for our panelists? Oh, wow. Excellent. 2 in the back. I keep calling that audible. Where'd our microphone go? Go, Dagmar.
The camera's fabulous. Should toss.
when you enter all this data that you are associating
Hi.
with the camera shots and where physically you're recording, how do you keep that data associated with the massive video footage that's been moved from live, to equipment, to
Time code. It's always been a real challenge. So, the system we've built now has been built on the basis of time code. So if we say, take the example of baseball or golf. So you get those traces that, that's the data that comes into us of the trace. We visualize it. Once it's gone on the picture, they can't take it off. And they can only do it on so many cameras. The system we've built now has taken advantage of time code, and all of the data that we are sent is now recorded in the time code. So the pictures are always clean, and so the user can decide when and where and whether they put the graphic over the top. Then and it only goes up while it's broadcast. The picture remains clean. It also means that any user can put their own color graphics, their own graphics, but timecode has been the absolute core of the platform.
what file data is right? What do you hit?
Talking about what I think Dan mentioned, the idea is to make it really simple. So if we see ESPN using it, they have this remote operation and they know that this button puts this on, that button puts that on. Everything happens in the software behind it. So our job is to make their job really, really easy and allow them to capture us, to visualize all of the data in any way they want. But I have to say, you're asking the wrong person. I used to be a singer in a rock and roll band, and that's my extent. I don't understand any of this amazing technology that our team pulls together. I just have this broad view that it's magic, and it gets me to all the best sports events in the world for free.
It's a great example. Thank you.
My name is Kim. I'm an artist. Just my way to be able to sort the entire. You told me today about book distribution, automation, and API cooperation. But as an artist, I'm wondering how are you using your systems to help, like, living artists collaborate with AI? Like, for example, how are you helping us on board?
Yeah, very quick. And our driver is that the art and storytelling is the most important. So those graphics you saw up there are the result of human interpretation of data for storytelling. So artists are incredible. We have a big graphic artist team and and the computer programmers. So we think that storytelling is driven by humans, and AI is simply another tool, a powerful tool to help them tell better stories. But we need the humans there to tell them.
All right. Thank you again to our speakers. Thanks for coming up here on this quick Q&A.